and back to the tutorial for operating system. This is a tutorial definitely helpful for whoever preparing the competitive exam like UGC Net, GATE and so on. Today we are going to discuss some of the memory management algorithms called first bit, next bit, best bit and worst bit. The shortest way. Please kindly check the video sequence in your doubt and subscribe when you like the channel and share with your friends. So here the first bit, best bit, worst bit. Because what will happen here? Let's see the diagram here before seeing this one. There will be diagram given. Let's say the process come to OS where there will be used memory space denoted by yellow color, and remaining are upcoming process. We can allocate the P1 at runtime P1, P2, P3, P4, P5 and so on. So here what happened in the first bit means in the first bit approach, what happened means it allocate the first free portion are whole large enough which can accommodate the process. Let's say example here. Let's say P1. So let's say I have P1 process with come with the 10 KB. Where I'll check from the starting. This is a place where I have 20 KB, so we can easily accommodate here. So P1 is a process having the 10 KB. The memory portion come with 20 KB. Is it possible to accommodate? Yeah, possible to accommodate. P1 can accommodate here. So remaining 10 KB left here. 10 KB unused space here. And here the advantage is the fastest algorithm because it fetches as little as possible. And one disadvantage here, the remaining unused memory areas left after allocation becomes waste. Then you see here next fit algorithm. Here it's began as first bit to find a free portion. Moreover, when called next time, it starts searching from where it is left off, not from the beginning. Start search always from the last allocated code. Let's say the example here. Let's say the P2 have process come to P2 KB and assume that there is virtual pointer given here. Virtual pointer denoted in the P1 process. So here the virtual pointer is a so the this one start from the next one where already virtual pointer from next value here used one here it will go and check. 12 KB can be accommodated here means possible. Yeah. So it will accommodate here and finish it. So 12 KB accommodated, remaining some KB will be left here. That means least. That means you can start search always from last allocated only. Then next is called best bit. Here what happen means it always deal with one allocating the smallest free portion which meets the requirement of the requesting process. Moreover, it first searches the entire list of free portions and consider the smallest code that is adequate. That you can say remaining portion will be least. Let's say example here remaining portion will be the least. That is example. In best one what happened means let's say the process P1 come with the 10 KB, it go and search already this is over. So P1 here, if you use it here, what will happen? 15 KB will be there. If you use it here, here 40 KB will be there. If you use it here, 60 KB here. So where it means this is substance. When P1 want to accommodate the memory portion, it go and select the this process. So remaining 5 KB left here. So there will be some free portion will be there. This is called best fit. So remaining portion will be least only. Just so wherever you go and accommodate, let's see here. So because here only 5 KB, if you go here 30 KB wasted, if you go here 50 KB something wasted here. So this is the one example for best fit. And advantage here, memory utilization is much better than first fit, and as such as the smallest free portion partition first available here. Disadvantage also there, that is very slower. It's always slower. And let's go next one worst bit here. This is the one where locate largest available free portion so that the portion left will be big enough to be useful here. It is a reverse of best fit. Remember, so worst fit what is one of the memory allocation algorithm opposite of worst fit. And also let's see the example here. So here what will happen? Let's say the P2 come with the 12 KB. It go and check where the memory portion is with the largest space. Suppose if you accommodate here 3 KB only left. If you accommodate here 12 KB, 28 KB left. But if you go and accommodate here, what will happen? It 60 minus 12, 48 will be 48 KB, 48 KB left here. So it will go and check the largest portion where the process will accommodate it, and it will say the memory space, largest space available. So if you go 25, only 13 KB is there. So it will go and accommodate here memory portion of 60 KB here. That is a worst fit. Okay, so it's saying here portion left with big enough hole. That's an advantage here, reduces the rate of protection of small cache. And disadvantage is that if a process requiring large memory arrays at a large stage, then it cannot be accommodated as the large code is already split and occupied. So when you go for exam, they'll give the diagram like this and ask what is the use of first fit and first like that. So out of this, which is best means first fit is the best memory allocation algorithm compared to others. So remaining, if you have any queries or suggestions, please kindly communicate with the following social media. And thank you for watching the video. Please like, share, comment, and subscribe.